Hello there, welcome to lesson number 5 in our series on using FluidDesigner for 3D printing to create lampshades and desk lamp covers. Today's lesson we're going to show you how you can create an octagonal wireframe lampshade. So if you start off FluidDesigner, your opening screen should look something like this. If we go to Learning Projects, Lighting Projects, we need to go to lesson number 5, so it's 05 octagonal wireframe lamp. And I'll just switch on the screencast keys, so any key presses I make should be displayed in the window here. And I'll just close that one just for the moment and just move this window back. So this is what we're going to create. So it's a wireframe octagonal shape lampshade. Okay, so it is quite open in its appearance, and what we're going to do is we're going to create it from this object here. And this object can in fact be found if you go to our templates folder and go to cross sections. Hang on, I just need to click group library first. If there's nothing displayed here, just click group library. So if I go to 3D templates cross sections, there are a number of different cross sections that you can use: triangular, circular, square. The one that we're using in this lesson is the octagonal one, so it's the 8-sided shape. So that's what we've got on our screen here. There is one slight difference between the one that's in the 3D templates and the one we've got on the screen here, and that is the handle type. The handle type on the one in the 3D templates is set to be automatic, whereas the handle type on this one is set to be vector. If I just go to view and view this one from the front, I'll show you quickly what that means. If I just press A on the keyboard and select, and I did it again a second time, that selects all 5 control points along this Bezier curve. And if I right click the mouse button and if I change the handle type to automatic, you'll see the effect on this object is that it makes it rounded in shape. Oops, I shouldn't have done that. Whoops. I want to select one control point at a time. Yeah? This looks very rounded now. If I just do A again and A to select all, and if I just change the handle type back to vector, you'll see with vector we get straight lines between the control points. So in the 3D templates it starts off as rounded, but you can always change it to vector by changing the handle type. So in this lesson we're going to modify that object there. We're going to enlarge it and make it look like this wireframe over here. So I'm going to have to keep zooming in and out, I should think, to select these control points until we get the sizing roughly right. So I'm going to drag that one up there. That's the top control point. The second control point, I'm just going to drag it up. The one at the bottom, I'm going to drag it right down. And I'm just going to move this one down and move it out a little bit. So I'm just resizing, repositioning those 5 control points to just try and line them up with the size and shape of the object on the right hand side. So we just widen that up a little bit, and there, and that one as well. I think I need to just move that down a little bit and in. Okay, and I suspect that wants to come up a little bit, and that one as well, and perhaps out a little bit. Okay, so that's the shape that I'm going to use today's lesson. It's not exactly 100% the same as the one on the right. If you actually had if you actually had drawn this octagonal wireframe lampshade on paper and you had actual dimensions for it, one of the things that you could do is in the transform panel here, when you do select a control point, you could enter in particular values here to create exact dimensions for this object. You would need to switch to local, display the local value. So that's saying that this point here is minus 55 millimeters from the vertical axis. So in other words, that's about 55 millimeters there. So the width of this is about 110. The Z value minus 97, it's minus 97 down here. So we could, for example, enter in minus 100 there, minus 100 millimeters. And we could enter in minus 50 millimeters there. And if we zoom in, you can see that that control point now, it's exactly 5 centimeters, 50 millimeters from the center. So this is exactly 100 millimeters wide. And that's exactly 10 centimeters or 100 millimeters down from the Z-axis. So you could use these control point values here to enter in exact sizes. But I'm going to leave it like that today, and I'm going to now come out of edit mode. And so the next thing we want to do is that this main object here is actually a curve. It's actually a Bezier Circle curve, and we can't print curves. We've always got to change curves into meshes. So once we've got this general shape that we want here and we're happy with it, we can go to Tools, Object Tools, and we can convert that to a mesh. And as you can see, it changes to a white shape, similar in appearance to the one on the right. What we now need to do is to change it into this wireframe. Well, we can do that using the modifiers in the Properties window. So if we click on Add Modifier, the first modifier we're going to apply is a wireframe modifier. And what the wireframe modifier does is it takes out the individual faces here, and it just leaves us with this wireframe of the original object. Now you can see that I didn't quite get this position for the control point in quite the same place as I did in the finished object. I put a control point here. I should have been a little bit higher, but not to worry. So view and front. Now in the wireframe modifier panel there are some options that we can change, and if I just scroll down here we'll just see what the settings are. We want to leave the thickness as 0.02, leave the offset as 0, and we want to tick even thickness. So an offset of 0 means that where this wireframe is, when we apply some solidify modifier and thicken it up, the offset of 0, it will put it thicker on the outside and on the inside, so it will do it evenly. I mean, that's what the offset will do. Okay, so we've got a wireframe now. We've got rid of some of the faces. What we now need to do is to add some thickness to this wireframe, and we do that by using a solidify modifier. So we go to Add Modifier and Solidify Modifier. And the values that we want to set for that are 2 millimeters thickness. So if we zoom in, we'll be able to see what that does. So 2 millimeters thickness. I'll just take it back down to the wireframe again so you can see clearly what's happening. And in our instruction panel here, we want to change the offset from -1 to +1. So one of the things you've got to do with this wireframe modifier is look closely at the finished product and see what it looks like. Does it look as smooth as possible? And if we change the offset back to -1, what you can see is if we zoom in, there are some strange bits going on here. And so as we change the offset, you can see it affects the appearance. And what you've got to do is you've just got to look at this object and see which looks the smoothest, which is going to give the smoothest finish when you print it. So visually looking at it is the only thing you can really do with these offset values. There's no simple rule to this. So what we've got to do now is we've got to apply these modifiers, and we do that by going to Tools, Object Tools, and converting to a mesh. And so the modifiers have been applied now, so we can put that out of the way. So there's our wireframe octagonal lamp cover, and so what we can do is we can delete the original, and we need to save this now. So if we go to File and then always go to Save As in FluidDesigner, don't save it in Learning Projects, just go up through the menu system, go to My Projects, Lighting Projects, and you can save it as Lesson 05, an octagonal wireframe lamp, and you save that as a Blender file. Now you can't print Blender files, so we need to go to File and Export, and we can export this as a wavefront object. We like to export it to the desktop, and then what we need to do is to go to Netfab Basic and go to Project and Open, go to the desktop and open up the project 05 octagonal wireframe lamp. Now we haven't got any warning red triangles, but we would always recommend you go to Extras and Repair the Part, and click Update. Well, there are no border edge problems, no orientations, no holes, there's only one shell, but just run automatic repair anyway, and apply the repair and remove the old part. So what we need to do now is to save this. So if you go to Part, Export Part as a wavefront object, export it to the desktop, and you can export it as the repaired file now. And that's the one that you would send to the printer. Now I should say that with all of these lamp fittings, the cost of actually printing this at today's prices is very high because of the sheer size and volume of such objects. But this just gives you an idea of what you can do in FluidDesign. Okay, so that's it. That's the end of this lesson. Thank you.